Okay, Bismillah. This is just in case anyone is interested or need to get some comments on how to address the previous quiz. So yeah. All right. So this is the previous quiz. I think you can see it in your screen, right? So where we have questions, two questions, I think, with regard to moment of a couple. One in 2D, one in 3D. Right. Okay. So Bismillah. So first off is on the 2D question. Normally, if you have question in 2D for moment, it should be generally straightforward, except for perhaps some of the question in the tutorial, which is from the previous exam. It can actually test you on how to say whether you are aware of every distance, or meaning, for example, some position does require you to add a certain distance that some student might not realize. Sometimes that's the only challenges, right? For this question, based on the diagram below, determine the resultant couple moment acting on the beam. State the direction of rotation of the moment. Right. Of course. Again, so far in our quizzes, you know exactly what topic or which topic it is related to, right? So it is quite straightforward because you know already. Okay, this is the topic, so this is the equation. It's just that how to solve from there on. But in your exam, meaning similar diagram can be from or can ask for different concept topics, etc., right? So you have to understand when you read the question, this is regarding which topic. So that is crucial for your, including for your midterm, right? Because sometimes it is about moment about point, sometimes about moment about an axis, sometimes about um, couple moment. And of course, fortunately for you, it does not include the simplification, because the same diagram can also ask about simplification uh, of force and couple moment system, right? So in a way, fortunate that for the midterm we do not go until that point, so at least less confusion perhaps for some students. Anyway, going back to this question, so by reading the question, you know that this is about couple moment. And so normally the easiest way to address question like this is by resolving into the component, right? So each of these will have the vertical and horizontal components similarly here, right? So as long as this one will be straightforward, the vertical will be 10 3 over 5, which is 6 kilonewton, and the horizontal will be 10 4 over 5, which will be 8 kilonewton, right? So this will be the same here, 8 kilonewton, 6 kilonewton. Now, once you have established that, then the couple becomes easier to solve because the perpendicular distance is quite clear. So if we go from here, um, so we have the horizontal forces making one couple, so one in this direction, one in this direction, where it is 8 kilonewton each. And then the vertical component is just this distance, which is 1 plus 1, which means it is uh, 2 meter. So that is one couple. Another couple is the vertical forces. So you see it here. So it will be 6 kilonewton couple. And the distance is this length between the two vertical force, which means it is 4 meter. Right, so we have established the two set of couple. One is the set for the horizontal, which is 8 kilonewton. One is the vertical force, which is 6 kilonewton. So from here, the rotation should be clear, right? Meaning that here you can imagine the rotation to be clockwise for this one, in this case it's also clockwise, right? So obviously when you add together it will be clockwise as well. So you might want to just use summation of moment in clockwise as positive. Okay, not enough space, is it? Oh, so we'll mana nak sambung eh? Okay, I'll just write it here. Summation of moment, couple moment, uh, taking clockwise as positive, so that obviously the answer will be in positive, right? So for this one, it will be just straight away 8 times 2. It's positive because it's clockwise, because we are taking clockwise as positive. If you take counterclockwise as positive, you will get negative and negative, of course. And for this one, also positive because it's clockwise, so 6 times 4. And then straight away you get your answer. And because all of this is positive, and then when you see state the direction of rotation, so obviously it is clockwise, right? So this one is obvious because both component makes a clockwise rotation, right? It will be less obvious because if one is clockwise, one is anti-clockwise or counterclockwise, then you have to see whether the answer is positive or negative, and then you know whether it's clockwise or counterclockwise. Right, so that is for the 2D problem here. So the steps will be the same regardless of how many forces that you have, right? Just resolve everything, just pair up all the couples, and then just one by one. Once you have in this form, it's quite straightforward already. Force time distance for every component that you have, right? If there are more forces in the question, right? So that is for the 2D problem here. Next, we will go to the next one, which is a 3D problem. This one. Based on the diagram below, determine the magnitude and coordinate direction angles of couple moment acting on the pipe. Right, for this question, even though it is also straightforward, I think, it's just that sometimes some student may get confused when the question straight away asks for the final form of the answer should be in the magnitude and coordinate direction angle, right? So in the end, what is m in magnitude and alpha? Oops. What is alpha? What is beta? What is gamma? Right. But you should know already that if you already have the vector of moment, then to get this magnitude is just square root of the whole thing. And then alpha beta gamma, you can know the x component and the magnitude, y component and the magnitude, z component and magnitude. You can already calculate alpha beta and gamma, right? So it will start with vector operation, despite the final answer will be in this format. So in this case, the okay, in this question, it does indicate already, right? For example, here, the couple moment, right? So it is clearly stating that this is couple, right? I'm not sure whether there will be question where that is not clearly hinted, meaning that you have to identify yourself. So that would be, but the answer will be the same regardless, right? It's just that it might be longer. But anyway, in this case, we know this is couple moment. So as you can see as well, 3 minus 4, 4, and here minus 3, 4, and minus 4. So it's just the opposite when it is couple, right? Because it's opposite direction. So what we will be using is for couple moment is m equal to r cross f. By now, you should already know what is this r. This r should be, this r should be, because it will be from one force to another force, and then this f should be in accordance to that, right, using your right hand rule. So in this case, if your option is r a to b, from here to here, right, and f will be f b. If it's the other way around, then of course that's also okay, but the answer will be still the same. If you use RBA, obviously for f is FA, right? Because R is here, F will be this one. Yeah, if R is here, F will be that one. Okay, hopefully you have understood this one, because if you make a mistake here, the answer will be wrong, and the concept is wrong, of course. So you lose everything from the beginning, because if you get the wrong concept, then your mark will, meaning from there on you will lose all the marks going forward, right? So yeah, avoid those kind of mistake, right? Make sure you understand. Okay, so in this case it's just I think the rest is just mathematical calculation. If I use, for example, if I use this one, so then just okay, if we do, where should we do it? Okay, M here. If I jump steps here, but you know how to use this one using matrix, right? So in the end it will be I J K, and then you'll put the R A B, for example. So R A to B for X, in this case it will be what? X will be -2. No, sorry, -3, right? This is X. So from here to here, so it will go in that way. So -3x. um, J will be, in this case, -2, and then Z will be 1 plus 1, so 2 plus 2. All right, so it'll be like this, and then F will just use FB in this case, so it will be 3 minus 4, 4, right? And oops, yeah, anyway, so you can solve this one and get something in terms of ijk, right? So obviously the answer is in the magnitude format, so it's just that once you get in our ijk, you know what to do, right? And then alpha beta gamma also, you should know what to do there, right? You just take the x component here, or if I'm just writing it here, mx, and then m here, right? And then you can solve for alpha beta and gamma. That is basically how you solve this type of question, from knowing what is the final answer look like, and then how to get there, right? From the basic equation onwards, right? So make sure you understand, especially for couple moment, make sure you clearly state which R are you taking, for example here, RAB or RBA, and then F, which F are you talking about, or taking, FB or FA. And then step by step, especially in your exam, make sure you do not, any major steps do not skip, because you will skip the marks as well, right? So make sure everything is in order in your paper. All right, so that is based on the quiz from last class, which is about couple moment, which will be part of the syllabus that is covered in your midterm, right? So that's the last topic that will be covered in your midterm. The probability of having a question on couple moment is quite high. So make sure you do not lose any marks there, right? So that's it for the explanation for the previous quiz. Any question, please, you can ask, of course, as usual. Any other question as well, please feel free to ask. From if you have any question with regard to any chapter leading towards your midterm, feel free to ask as well. All right, so that's it for this quiz. Um, yep, you can continue on with whatever exercises, tutorial, question. So in this case, I think for most of the student, I hope, oops, it should be clear by now, because when we talk about the rotation, it also is just the same concept as what we have learned in moment about a point, right? And basically this is goes back to the moment about a point anyway, right? When we talk about, when we're calculating moment, it's about moment about, it is basically moment about point. So when we talk about rotation, right? Because when we talk about, for example, point, the difference between part A and part B in this question is that part A is about point A. Oops. Yeah, it's about point A, and then this is about point B. That's the only difference. The other forces, moment, etc. is the same. So if you look at about point A here and point B here, now the effect of rotation will be different by different forces. For example, if we are talking about let's see, this 650 Newton, if we're taking the vertical component, about this point it will create counterclockwise rotation. About this point is still counterclockwise rotation, right? It will rotate this way. So that is should be quite clear. For this force, obviously about point A, it doesn't create any moment. It goes to the point. About point B, it will create this rotation, right? So it will be counterclockwise. For this force, about point A, it will rotate this way. So it is clockwise, but about point B, it will rotate this way, right? It's counterclockwise, right? So, sorry, this is clockwise, yeah, this is counterclockwise. So that's how we determine the rotation basically, right? Meaning that if we have the pivot here, obviously this will rotate this way. If the pivot is here, it will rotate this way, right? So yeah, hopefully that explains the rotation. So that's why I want to ask actually, how do you see the rotation to be clockwise or counterclockwise? Because it is meaning what is the effect of any particular force to the point itself, right? So I prefer to understand how you conclude in a certain rotation first before explaining, because I want to know. Yeah, generally I would like to know how the student see it first, then to identify where the mistake is. Right, but anyway, this is the explanation about the rotation.